Hello, everybody. Welcome to this session about modules in SLE 12 and SLE 15, about the similarities and the differences there. My name is Stefan Behlert. I will show you a little bit an overview of the product portfolio and SLE 12 and SLE 15 and why we choose to have modules there. We will go then a little bit into the characteristics of the modules and comparing the different code bases. And at the end, I will go a little bit into the module and the details of these modules so that you have a good overview about the module content. With that, let's start and have a short look at codebase 12 and 15. Some of you may still remember SLE 11 or even have still in use. It's getting close to the end of its life cycle. LTSS has ended when you're looking at this presentation. The SLE 11 codebase was relatively simple. It was one ISO image. For each type of server that existed, be it SLES or SLES for SAP, one ISO image, a big monolithic blob that you downloaded. Everything on it, no addendums to that. You just installed the updates on top of that. No additional package. With SLE 12, we decided to change this and go more modular with that. You still were able to download the big ISO blob, but on top of that, you could get modules online that enlarged the universe, that provided additional functionality. You also had the extensions that were available, the HA and the real times of this world, so that you could really get your basic system that you had bigger and with more functionality on top. But there were still some inconveniences. For example, that big ISO image. And with the future code stream that we had then with SLE 15, we decided to go further down that modular road. And we splitted the ISO, the big base product, into more modules, which allows finer granularity, allows to combine them in a different way, and also to be very selective of what you download and what you need and what you want. So why modules at all? I mean, why that split? Why being selective? Why being chooseful? Well, in the end, there are two types of customers on the both extreme sides. There's a wide variety in between, but let's stay at the extremes a little bit. We have the customers that want to have slow changes, that want the stable interfaces. They want bug fixes mostly, not so much features, and they want the bugs that they have being fixed so that the fix is especially for them and their needs. They want as few updates as possible and definitely no regressions or changes in the behavior. But they also want to support many applications, especially those that they need. On the other side, you had customers and users that want to stay current, that want to have the latest and greatest while still stable, but the latest and greatest that is available, that wanted new features when they are upstream available as soon as possible also into the enterprise products, that wanted to use different form factors and have on the other side, besides all of that that is coming, new innovation inside of the updates, inside of the ongoing deliverable. And the downloads should still be small. That's something that nearly everybody wants. Small downloads so that you really have an attack surface that is as minimal as possible. But it should still contain everything you need. SUSE has one very big principle, and that's stability. We do not break existing ABIs and APIs. Yes, in some cases, this might be needed. Very extreme, very rare, when you have critical data loss situations or security fixes that are not possible to fix without breaking an ABI. But in most cases, it's sufficient to add new APIs and ABIs, and thus stability can be guaranteed. On the other side, if you want to have bug fixes or new features inside of an application, there are two ways. You could on one side simply take the next version that is available, which has most likely the bug fix that you need, has a few features inside, but also will most likely introduce new bugs or have features that you need to test that you don't want. So we normally do updates through backports, fixing bug fixes for the version that we have shipped, adding also some features there, and not so much going higher up with the version number. There are cases when this is useful and sensible and reasonable, but it's not the general stuff. Bug fixes are done through targeted changes, so not a simple version update, which may make the situation worse because you have new unknown bugs, but rather have an update that fixes the bug for that version. But there are also two dilemmas. On the one side, for us, we have a long support term of 13 years that comes to each of the content that we have inside of our products. And not every upstream project has such a long life cycle. Definitely not for a specific version. So there is software that leads a faster life, but our system there is set up to have, a long life. On the customer, the more packages and version he gets, the more he has to struggle to keep the overview. He may have internal reviews and efforts ongoing to verify all of the downloads, all of the version that he downloads and installs. And what about his attack surface? The more packages, the more highly likely it's you get something that you don't want, and that opens up doors at a place where you definitely don't want them. There's a simple way out of that. We decided to use a very old concept, divide and conquer. Nothing new there. We defined groupings of packages based on two criteria. One is the use scenarios, the other is the life cycle. We distinguish there between the must-haves and the additional groups. So you can have a group of packages that is a must-have that you definitely need if you want to run the system. Think about the usual tools like kernel, systemd, and other stuff. And there are additional groups that you may need only in specific use scenarios. If you, for example, want your image to be enabled inside of a public cloud. Not everybody needs that because there are also images in the public cloud from us. But if you need it, then it's nice to have it. And this would be an additional group. And we also looked at the download size because the smaller it is, the better it is. You don't need to download all package groups. That costs time, that costs resources, and it gets on cost of the overview. So by reducing the download size, we also reduce the review needed. We added more structure on getting things that you need and not to overlook stuff. So we ended up with the package group, and the package groups were simply modules. A module is nothing more than a collection of software packages. There's no specific magic. There is no need to download a special tool to handle them. All the packages inside of a module have some logical functional cohesion. They have support. They have perhaps some scope limitations compared to the base products, but they are definitely delivered in the same way as the rest of the system, as a repository, as an addition to our base products like SUSE Linux Enterprise Server, like SUSE Linux Enterprise Server for SAP applications, and they are part of the distribution. They can have a different life cycle, both on the package level as well as on the module level. A module is not a pattern, keep in mind. There may be patterns inside a module, and some of the modules use patterns to install a default set of packages, which you normally would need if you want that module, but they are not a pattern. There's more inside than just a pattern. A module is not always independent of other modules. So you have a requirement there, a tree that is on top, because we wanted to keep the download size small, not to have duplicates inside. And in that way, you have the dependencies. The modules tells you which one they need when you install it. So you should not run into problems. And not every module is available for all of the products. Not everything makes sense, and therefore some limitations apply. Now let's have a look at 12 versus 15. You may ask, why are there differences on the module side between 12 and 15? Well, you know how it is with building bricks. There are different sizes. You can combine them as much as possible. But if you have some with big knobs and some with smaller knobs, they may fit, they may not fit. They have different target groups, and they have different platforms where you build them upon. The same is true for the modules and the code bases. Let's have a look at SLE 12. SLE 12, I said it, a monolithic product design with additional modules. You see it here. You have the containers module, certification module, but you also had the extensions that needed an extra registration code that you could put on top of the base module and the base product. And you had an SDK. The SDK was containing all the development tools, but also the devel packages for all of the products that you see. Which also means if you had the SDK, you sometimes had a devel package downloaded for a product that you don't even have and don't even need, which is a little bit awkward. But as the nature of the design on SLE 12 said, it is as it is in that regard, and we decided to change that to make this better with SLE 15. On SLE 15, a module forms the product. It identifies the product, and it provides functionality that's either core to the product or that is on top. You see it here in the middle of that drawing. There are the common code-based modules where you see the base system, the desktop apps, and many more. Those are the fundamental modules. These are present in all of the base products, so in the server, in the SLE for SAP, in the desktop, because they contain basic libraries, functionalities that you need there. On the other side, you have modules like the server apps, which are only present in the server modules, in the server products. These are not available for the desktop product because they have server applications that you need on servers normally. And you have a big pool of modules that are available for free on top of all of the products that exist. With some caveats, as mentioned, not everything makes sense, and therefore some restrictions apply, but you have a wide variety of modules available. Similar between code 12 and code 15 is that not all of the modules, as I mentioned, are available for all products. They can in both code streams being added with the SUSE Connect, just like an extension. And once a module is added, you have all the tools that are inside available. You can use the regular tools that you are familiar with. It's a repository, as said. No magic, no additional stuff needed. Use RPM, use Zipper, use Yast, whatever you want. As long as it can handle RPM, you're fine. But we talked also about lifecycle and that the content lifecycle of a module may be different compared to the base OS. And for that, we have the super lifecycle command, which provides you information if, for example, a language has been replaced or will be replaced with a newer version at a certain point of time, or if you are safe of using it for the next few decades. There are also differences, and those differences are important. On sleeve 12, a module is service pack independent. That means you get one repository for the whole life of all of the service packs, which also means there's a lot of stuff inside, and not all of them applies to the service pack you're running. But you have the advantage, it's just one repository that you add. An exception is the certification module, which was always only valid for 2 service packs due to the nature of that module. The modules there are additional content. So everything that is base to the server is in the base product. A big disadvantage there on 12 was that the modules are only available online. So there is no media download. But as I said, it's additional content only. So you should, in most cases, be fine with that. And there's no product identity module. A product identity module is needed on SLE 15 because everything is a module. How do you define that you have a specific product installed? And that's done with the product identity modules, which have updates for the release notes, for the release packages and other stuff inside. But that, of course, doesn't exist on 12. On SLE 15, we made the module service pack bound. This makes the download smaller. This makes the potential confusion smaller because you always have only the packages that are valid for this service pack. The modules can provide, on the other side, now essential content. The base system module, for example, is essential. Having a system without it is not possible. So the modules have changed their nature there also a little bit. But the good thing is you have no additional duplicated downloads of packages. On SLE 12, you had the big ISO for SLES for SAP, the big ISO for SLES for HPC, and they had duplicated content. If you downloaded it, you had several times the same package. Awkward, isn't it? Yes, that's why we have SLE 15, where we avoid that, where we change the structure. So if you have, for example, SMT or RMT used, you get only one time the base system module, one time all of it, no duplication. And of course, you say maybe, I'm not a big fan of online. What about offline? Yes, you can download one image with all of the modules inside, and that's the big advantage you then have because all of the modules are there, all of the products, and you have also there no duplication. I will not go too much into details of the types of modules. You can see it here. Please download the presentation to look this up closer in case you're interested. But let me phrase out that we have also non-SUSE modules that are provided either by the community or by third party. Examples, for example, here, the package hub or the NVIDIA repository, which comes on top of the various products. Same is true for SLE 15, only minimal changes there. So you can see that for yourself. Let me get a little bit into some selected modules. You see here an overview between SUSE Linux Enterprise 12 and 15 and what's available in which code base. Be aware, for SLE 12, most of those modules are already part of the download of the big blob. They are not identifiable as a module or in the module name that you see here, but that's then different on SLE 15. You have here also a few special types of module, the high availability and the workstation extension, for example. Those exist as modules, but also as a product because they are extensions that are available with an extra registration code on top of several base products. I said it already, we split up the SDK. I've chosen to put the SDK into a more useful way into the various modules. So all the devel packages are where the binaries are. So when you install a module and you choose a module, you have also the devel packages in the respective service channel for that module, and you don't have to install an additional SDK on SLE 15. The development tools itself have been moved into the development tools module, where you can get all of them, and you also find there an additional GCC. Why an additional GCC? Very simple. We use for a codebase 1 compiler version throughout the whole codebase lifecycle. This makes some things very easy and also reliable. But of course, you have always applications that you might want to compile with a newer compiler, where you maybe need a newer compiler even. And therefore, we provide on a yearly basis an additional new version of the compiler, which can be found in the development tools. The runtime libraries are, of course, in the base system. So if you compile something with that compiler, you can still run it on the product. No need to install additional libraries, therefore. Let me point out two modules here. One is at the very bottom, the Python 2. Python 2 has its end of life upstream wise since many years. You shouldn't use it. You should have moved all your Python 2 application to newer Python 3 versions, but we provided it now until SP3 so that you have time for migration and to move forward. But with SP4, it will be now decommissioned. I recommend here the session about SLE 15 SP4 that has more information about that and where you can get more information also with that regard. Instead of the Python 2 module, we will deliver with SP4 for the first time a Python 3 module, which will contain not only an additional Python 3 version compared to the system one that we have already in the base system, but also the packages, the module packages for the Python 3 version that we have there. This module will grow over the upcoming months, so be patient there and have a look out. It will get more and more packages throughout the year. Which module do I need? That's a good question, but it depends mostly on your situation. It depends which code base you have and what your use scenario is. On 12, the answer is most likely you're fine with the base product that you downloaded because all the modules are on top and the base product should have everything you need and a lot of other stuff. SLE 15, it's a little bit different because everything, we said it, is a module, but you definitely need the base system module. No way you can come and live without that. Each base product, slash for SAP, HPC, whatever you choose, has a default selection of modules that already gets enabled when you select it, be it online, be it in the offline media. This is normally a good choice and reflects mostly what had been in SLE 12 from the functionality choices. But you can, of course, enhance this with the modules that you need for your use case, or you can also strip it off if you don't need something, for example, because you want to get to a very minimal system. If you're migrating from an older code stream, it's wise to select the legacy module that contains packages, especially for that case, because with each major code base, some packages get decommissioned, get replaced by applications that better fit the needs, that are better from our point of view when it comes to the life cycles. An example would be NTPD and Chrony. But of course, there are complex situations, complex configuration scenarios, and therefore we have the legacy module where we add the stuff where we only provide critical bug fixes, but no new features for the old application to allow you to migrate in a longer time frame and not in a hurry. You should also check if you're affected by Python 2, Python 3, and if you need to install that module. So let's recap shortly. The modules allow you to get faster what you need to keep stability. They provide a clear structure. They are usable with the familiar tools that you have, and they can help you to reduce your attack surface and to help you setting the right expectation when it comes to the life cycle. In the presentation that you can download, you will also find a few module descriptions and details, so you can look this up and see what you need for yourself. Be aware which module is available on which code base is in the table that you have seen, so you might want to do some cross-checking there. Overall, it's a good way of reducing the footprint that you have, and we hope to enhance this in the next few code bases that are upcoming. With that, thank you very much. Enjoy SUSECON, and I hope to see you soon in real life. Thank you very much for listening. Bye.